See Standard 12th Maths, Chapter 8, Differentials and Partial Derivatives, Sum number 6. The problem is, let W is W of xyz. W is a function of xyz is equal to 1 by root of x square y square plus z square. Show that dou square w by dou x square, dou square or w by dou y square plus dou square w by dou z square equal to 0. In condition x, y, z are not equal to 0. Okay. So let me take the given function w 1 by root of x square plus y square plus z square. Let me take this function as 1 by, I replace root in terms of power, whole power half. So this is equal to x squared y squared plus z squared the whole power minus half. Now you will differentiate. Differentiate partially w with respect to x. Dou w by dou x. So minus half. Half comes in front. X squared plus y squared plus z squared minus half minus 1. We reduce 1 and partial. So we differentiate x alone, 2x. 2x. So this is equal to 2 gets cancelled minus x squared plus y squared plus z squared whole power. 2 is the LCM. Minus 1, 1 2s are 2, minus 2, minus 3 by 2. Minus 3 by 2. And write this x, 1x here. So minus x by, take the power as positive, x square plus y square plus z square, positive. So I bring it to the denominator, plus 3 by 2. Plus 3 by 2. So this is your dou w by dou x. So similar way you can write the other terms also, dou w by dou y. See here, we need the second derivative, dou square w by dou x square. So what I do? I differentiate this dou w by dou x. Dou squared w by dou x squared. That is, I differentiate partially this dou w by dou x again with respect to x. Again with respect to x. So you apply u by v method. U by v method. So here v square. See, otherwise you can do the uv method also, because both the product of two terms x and x square plus y square plus z square the whole power minus 3 by 2. You can apply the u into v method. U into v method. Any one of the method you can follow. Let me do this. U into v. That is, take this as u and this as v. So keep u minus common, keep x as common, differentiate this. So 3 by 2 comes in front, minus 3 by 2 x square plus y square plus z square. Then the whole power minus 3 by 2 minus 1. Minus 3 by 2 minus 1. Minus 1. Then, so term here x squared. So 2x plus x squared plus y squared plus z square whole power minus 3 by 2. Differentiate x. That is 1. 1. 2 cancel here. So minus common x squared. So minus 3 you have, minus 3 right in front, minus 3 x square plus y square plus z square. Take 2 LCM. So 1 2s are 2. So minus 3 minus 2 minus 5 by 2 plus x square plus y square plus z square whole power minus 3 by 2. See, next step. Here one term, this is here one term. Here x square plus y square plus z square minus 5 by 2. Here power minus 3 by 2. So just you take it as common. So the least power is minus 3 by 2. X squared plus y squared plus z squared. Minus 3 by 2 is the least power. And also I have minus here common. Just keep as it is. Minus. And here when I take this minus 3 by 2 outside, you will get in minus 5 by 2. If I take minus 3 by 2 outside, I will get minus 1. So minus 3x squared, x squared plus y squared plus z squared. You write this minus 1. And this is no extra term here, just fully we can take outside. So this is plus 1. So next step, you take this minus inside. So here minus into minus plus. You just have this common term x square plus y square plus z square minus 3 by 2. So this is plus 3x squared into x square plus y square plus z squared. The whole power minus 1. But if you take this minus inside, it becomes minus 1. So this is your dou square w by dou x squared. So we need to find the sum of this second derivative. So directly we can apply this dou, so we can find dou square w by dou y square. Similarly, I write this dou square w by dou y squared. So just replace x by y. So you write this first term as it is, x square plus y square plus z square whole power minus 3 by 2. This is common. So this, instead of this 3x squared, I write 3y squared, and this write this term full expression squared, the whole power minus 1 minus 1 minus 1. And same way dou square w by dou z squared. See, you will get marks for this terms only. X square plus y square plus z square whole power minus 3 by 2. 3z squared, x squared. I replace y by z. So x square plus y square plus z square, the whole power minus 1 minus 1. Now add dou square w by dou x squared plus dou square w by dou y square, dou square w by dou z square. This is equal to, see, common term here for in all the cases. So let me write as it is outside, x square plus y square plus z squared whole power minus 3 by 2. So inside the bracket, here you have this minus 1 term here. So the next term 3 also same here. Just we replace x square plus y square plus z square. So I take 3 and then x square plus y square plus z square, the whole power minus 1. So take that as common. So the rest of the term x squared then plus y square plus z squared. X squared plus y squared plus z squared. Then minus 1 minus 1 minus 1, you will get minus 3. Okay. See, this term x square plus y square plus z squared whole power minus 3 by 2. See, what about this? This is whole power minus 1 plus 1. Base is same. So minus 1 plus 1, you will get 0. We add the power 0. So anything power 0, you will get answer 1. So let me write that as x square plus y square plus z square minus 1 plus 1 minus 3. So x squared plus y squared plus z squared whole power minus 3 by 2. 3 into whole power 0. So the anything for 0 will get 1 minus 3. So what is 3 minus 3? 0. So x square plus y square plus z squared whole power minus 3 by 2 into 0. This is equal to 0. So this is what you have to prove. So you can do just one term for this. The rest we can write as similarly. You will get marks for this. See the seventh sum. V is function of xy is equal to e power x into x cos y minus y sin y. Then prove that dou squared v by dou x square plus dou squared v by dou y squared equal to 0. So v is in terms of x and y, e power x, x cos y minus y sin y. So you can take this as product of two terms. First step, I find dou v by dou x. Dou v by dou x. This is u and this is v. Keep v power x as it is. Differentiate v. So if you differentiate v here with respect to x, so keep the y term constant cos y. X, if I differentiate, I will get 1. Then this is full term y. So just you will get 0 plus x cos y minus y sin y. I differentiate e power x, so just e power x. So take e power x as common. You will get cos y plus x cos y minus y sin y. Minus y sin y. This is your dou v by dou x. Next find dou v by dou y. Dou squared v by dou x squared. Second derivative. Dou squared v by dou x squared. So again you consider this as product of the two terms, u term and v term. Keep e power x and differentiate this v term. Cos y 0, but here x cos y. Here cos y constant, x if I do, I will get 1 plus. And this y sin y also 0. So no need to write. Now keep v as it is, cos y plus x cos y minus y sin y. Differentiate e power x. So you will get e power x. So e power x. So now it becomes two terms. Take e power x common. Cos y. Collect the bracket terms. Cos y plus x cos y minus y sin y. E power x. Cos y plus cos y, 2 cos y plus x cos y minus y sin y. This is your dou squared v by dou x squared. Next you have to find what is dou v by dou y. Dou v by dou y. Differentiate the expression v with respect to y. So before that let me write what is v. So v is equal to e power x bracket x cos y minus y sin y. X cos y minus y sin y. Okay. Dou v by dou y. Here u into v, but here x term alone in the u term here you have. So you keep this as constant e power x. Differentiate only this alone. X constant. If I differentiate cos y, I will get minus sin y. But now apply here uv method, y sin y. Keep y here. If you differentiate sin y, cos y plus keep sin y. Differentiate y, you will get 1. So this is equal to e power x. Simplify the bracket terms, minus x sin y minus y cos y minus sin y. This is your dou v by dou y. Now find dou squared v by dou y square. Again, differentiate v with respect to y. Here e power x constant minus x. Differentiate sin y, you will get cos y minus uv method. Keep y and cos y is minus sin y plus cos y. Differentiate y, you will get 1 minus differentiate sin y, you will get cos y. So remove all the brackets. E power x minus x cos y. Multiply this with the minus sign. Minus into minus plus y sin y. Plus into minus minus cos y. Here separate term minus cos y. So e power x minus x cos y plus y sin y minus 2 cos y. So this is your dou squared v by dou y squared. So what is the problem for us? Prove that dou squared v by dou x square plus dou squared v by dou y squared equal to 0. I have to add these two expressions. This is expression number 1 and this is 2. So add 1 and 2. Add 1 and 2. Dou squared v by dou x squared. Dou squared v by dou y squared. You add the right side expressions. Here e power x is common. Write e power x. Then write the bracket terms. 2 cos y plus x cos y minus y sin y. 2 cos y plus x cos y minus y sin y. And write this term. This is dou squared. We have taken e power x common. So write the expression minus x cos y plus y sin y minus 2 cos y. See, all the bracket terms gets cancelled. Plus 2 cos y minus 2 cos y plus x cos y minus x cos y minus y sin y plus everything gets cancelled. We'll get 0. So this is the answer we are supposed to prove. Thank you.